Hi everyone. This lecture is about the course recognized as Computer Science and Programming, or Introduction to Computer Science and Programming. I think this course is really important for new students who want to pursue their studies related to computer fields. This lecture has two parts. First part is related to our course contents, or you can say goals of this course. And second part of this lecture is related to introduction of this course, which is our lecture's main part. This course is for those students who don't have prior programming experience and don't know much about the computer science course. Okay, let's start with the part 1. In this part, we will only discuss that what we will study in this course in upcoming lectures. In lecture 1, we will discuss the computer science definition. Then we will discuss the architecture of computer, and later in this lecture we will discuss that what is algorithm. We will also discuss few algorithm examples. Second lecture would be related to the introduction of operating system and architecture of the operating system. In the third lecture, we will study about the data storage techniques, data storage devices. We will also talk about some basic definitions such as bits, bytes. Lecture 4 would be related to data representation. In the lecture 5, we will study about the low-level languages, machine language, and high-level languages. In the lecture 6, we will learn some basic things about the software engineering. Lecture 7 is related to introduction to database. Lecture 8 is related to network fundamentals, and lecture 9 is concept of algorithms. Lecture 10 is about the introduction to programming, testing, and debugging. In the lecture 11, we will discuss some basic programs. We will also discuss about the loops and type of loop. In the lecture 12, we will discuss about the arrays. Lecture 13 is related to functions. Lecture 14 about the pointers. And in lecture 15, we will study about the structures. Lecture 16 is related to programming language comparison and introduction to object-oriented programming. In lecture 17, we will discuss about the string and we will have some introduction about the lists. In lecture 18, we will study about the single linked list with examples. In lecture 20, we will discuss about the double linked list. In lecture 21, we will study about the searching and sorting algorithms. In lecture 22, we will study about the merge sort array algorithm. Lecture 23 is related to object-oriented databases, and lecture 24 is overview of this course. Let's discuss the objectives and goals of this course. I hope after completing this course, students are expected to achieve the following major objectives. Number 1, basic understanding about the computer science. Number 2, understand how algorithms are processed by computers. Number 3, perceive the importance of algorithm and programming in computer science. Number 4, learning about the process of writing and debugging a program. Number 5, basic learning of operating system, software engineering, network fundamentals, and databases. Let's start part 2 of this lecture. In this lecture, we will study about the introduction of computer science, computer architecture, and algorithms. First, we should know what is a computer. So the definition is an electronic device for storing and processing data, typically in binary form. according to instructions given to it in a variable program. Or a computer is a machine that can be instructed to carry out sequences of arithmetic or logical operations automatically via computer programming. What is a program or a computer program? Computers have the ability to follow generalized set of instructions or operations called programs. These programs enable computers to perform an extremely wide range of tasks. Why we do need to learn programming? The answer is you can use programming for almost everything. Programs can control robots that can take help us in factories, restaurants, or even in other planets such as on Mars. These robots can help us to study the Mars surface and weather. Programs help self-driving cars know which way to turn, which is pretty important, right? Programs can be very fun game like Doodle Jump, Angry Bird. Programs are behind every website and apps. So what is a programming language? Well, a programming language is a formal language which comprises a set of instructions that produce various kinds of output. Programming languages are used in computer programming to implement algorithms. Examples of computer languages are C, C++, Java, Python, R. Most programming languages consist of instructions for computers. There are programming machines that use a set of specific instructions rather than general programming languages. Thousands of different programming languages have been created and more are being created every year. Many programming languages are written in an imperative form while other languages use the declarative form. The description of a programming language is usually split into the two components of syntax and semantics. Some languages are defined by a specification document. For example, the C programming language is specified by an ISO standard, while other languages, such as Perl, have a dominant implementation that is treated as a reference. Some languages have both, with the basic language defined by a standard and extensions taken from the dominant implementation being common. Many people use desktop computers at work, home, and schools. These computers are designed to be placed on a desk, and they are typically made up of a few different parts, including the computer case, monitor, keyboard, and mouse. The second type of computer you may be familiar with is a laptop computer, commonly called a laptop. Laptops are battery-powered computers that are more portable than desktops, allowing you to use them almost anywhere. Tablet computers or tablets are handheld computers that are even more portable than laptops. Instead of a keyboard and mouse, tablets use a touch-sensitive screens for typing and navigation. The iPad is an example of a tablet. Many of today's electronics are basically specialized computers, though we don't always think of them that way. Here are few common examples. Smartphones. Many cell phones can do a lot of things computers can do, including browsing the internet and playing games. They are often called smartphones. Wearables. Wearable technology is a general term for a group of devices, including fitness trackers and smartwatches, that are designed to be worn throughout the day. These devices are often called wearables for short. Game consoles. A game console is a specialized type of a computer that is used for playing video games on your TV. Many TVs now include applications that let you access various types of online contents. For example, You can stream videos from the internet directly onto your TV. In computer environment, the user that makes the use of computer. It also describes how the computational activities are performed on the computer. User interacts with the application software to fulfill his task. Application software asks the operating system for services. Operating system commands the hardware and provides the services to the application software. In this lecture, we will discuss about the hardware and softwares. We will discuss about the operating system in the next lecture, which is a system software. Let's discuss about the hardware first. Computer hardware includes the physical parts of a computer, such as the case, central processing unit, monitor, keyboard, computer data storage, graphic card, sound card, speakers, and motherboard. The personal computer, also known as the PC, is one of the most common types of computer due to its versatility and relatively low price. Most personal computers possess a monitor, a keyboard, a mouse, and a computer case. The computer case encloses and holds all of the necessary hardware required to store and process data on the computer. The motherboard ensures that all other inner computer hardware communicates with each other. The CPU executes instructions for running computer programs. RAM is responsible for the temporary storage of data while the computer operates. The motherboard is the main component of a computer. It is a board with integrated circuitry that connects the other parts of the computer, including the CPU, the RAM, the disk drive, such as CD, DVD, hard disk, or any others, as well as any peripherals connected via the ports or any expansion slots. Components directly attached to or to part of the motherboard include CPU, RAM, ROM, and buses. The central processing unit, which performs most of the calculations which enable a computer to function and is referred to as the brain of the computer, which get a hold of program instruction from random access memory, interprets and processes it and then send it back to computer results so that the relevant components can carry out the instructions. The CPU is a microprocessor. It is usually cooled by a heatsink or fan or water cooling system. Most newer CPU includes on a die GPU. The clock speed of CPU governs how fast it executes instruction and is measured in gigahertz. Typically values lies between 1 GHz to 5 GHz. Many modern computers have the option to overclock the CPU, which enhances the performance at the expense of greater thermal output and thus a need for improved cooling. Random access memory or RAM, which stores the code and data that are being actively accessed by the CPU. For example, when a web browser is opened on the computer, it takes up memory. This is stored in the RAM until the web browser is closed. It is typically a type of dynamic RAM or DRAM. RAM usually comes on dual inline memory modules in the size of 2 GB, 4 GB, 8 GB, 16 GB, but it can be much larger. Read-only memory or ROM, which stores the BIOS that runs when the computer is powered on or otherwise begins execution, a process known as bootstrapping or booting or booting up. What is BIOS? The basic input-output system includes boot firm and power management firmware. Newer motherboards use Unified Extensible Firmware Interface instead of BIOS. Buses. Buses that connect the CPU to various internal components and to expand cards for graphics and sound. A storage device is any computing hardware and digital media that is used for storing, porting, and extracting data files and objects. It can hold and store information both temporarily and permanently, and it can be external or internal to a computer or any similar computing device. Data storage is a core function and fundamental component of a computer. Input and output devices. Input devices allow the users to enter information into the system or control its operation. Most popular computers have a mouse and keyboard, but laptop systems typically use a touchpad instead of a mouse. Other input devices include webcams, microphones, joysticks, and image scanners. Output devices. Output devices are designed around the senses of human beings. For example, monitors display the text that can be read. Speakers produce sound that can be heard. Such devices could include printer, speakers, and monitors. Computer software, or simply software, is a collection of data or computer instructions that tell the computer how to work. This is in contrast of physical hardware from which the system is built and actually performs the work. In computer science and software engineering, computer software is all information processed by the computer systems, programs, and data. Computer softwares include computer programs, libraries, and related non-executable data such as online documentation or digital media. Computer hardware and software requires each other, and neither can be realistically used on its own. Based on goal, computer software can be divided into application softwares and system softwares. Application software. Software that uses the computer system to perform special functions or provide entertainment functions beyond the basic operation of the computer itself. There are many different types of application software because the range of tasks that can be performed with a modern computer is so large. Example of application software could be Microsoft Office. System software. Software for managing computer hardware behavior as to provide basic functionalities that are required by the user or for other software to run properly, if at all. System software is also designed for providing a platform for running application software, and it includes the following: operating systems, utilities, and miscellaneous software. Operating system, which are essential collections of software that manage resources and provide common services for other softwares that run on top of them. Supervisory programs, bootloaders, shell, and Windows systems are core parts of the operating systems. In practice, an operating system comes bundled with additional software, including application software, so that a user can potentially do some work with a computer that only has one operating system. Device driver. Device drivers are also a type of system softwares. Device drivers operate or control a particular type of device that is attached to a computer. Each device needs at least one corresponding device driver, because a computer typically has at minimum at least one input device and at least one output device. A computer typically needs more than one device driver. Utilities, which are computer programs designed to assist users in the maintenance and care of their computers. Miscellaneous softwares, which is the software that is developed to harm and disrupt computers, such as malware is undesirable. Malware is closely associated with computer-related crimes. Let's discuss about the computer architecture. A central processing unit is also called a central processor or main processor. Is the electronic circuitry within a computer that executes instructions that make up a computer program. The CPU performs basic arithmetic, logic, controlling, and input-output operations specified by the instructions. The computer industry used the term central processing unit as early as 1955. Traditionally, the term CPU refers to a processor, more specifically to its processing unit and control unit, distinguishing these core elements of a computer from external components such as main memory and input-output circuitry. The form, design, and implementation of CPUs have changed over the course of their history, but their fundamental operation remains almost unchanged. Principal components of a CPU include the arithmetic logic unit or ALU that performs the arithmetic and logical operations, processor registers that supply operands to the ALU and store the results in ALU operation. Most modern CPUs are microprocessors, where the CPU is contained on a single metal oxide semiconductor integrated circuit chip. An IC that contains a CPU may also contain memory, peripheral interfaces, and other components of a computer. Such integrated devices are variously called microcontrollers or systems on a chip. Some computers employ a multi-core processor, which is a single chip containing two or more CPUs called core. In that context, one can speak of such single chips as sockets. In computer engineering, computer architecture is a set of rules and methods that could describe the functionality, organization, and implementation of computer systems. Some definitions of architecture define it as describing the capabilities and programming models of a computer, but not a particular implementation. In other definitions, computer architecture involves instruction set architecture design, microarchitecture design, logic design, and implementation. The discipline of computer architecture has three main subcategories. Instruction set architecture, or ISA, defines the machine code that a processor reads and acts upon, as well as the word size, memory address modes, processor registers, and data types. The second is microarchitecture, also known as computer organization. This describes how a particular processor will implement the ISA. The size of a computer's CPU cache, for instance, is an issue that generally has nothing to do with the ISA. The third is system design, includes all of the other hardware components within a computing system, such as data processing, other than the CPU virtualization and multiprocessing. At the end of this lecture, let's discuss about the algorithms. In mathematics and computer science, an algorithm is a finite sequence of well-defined computer implementable instructions, typically to solve a class of problems or to perform a computation. Algorithms are always unambiguous and are used as specification for performing calculations, data processing, automated reasoning, and other tasks. As an effective method, an algorithm can be expressed within a finite amount of space and time and in a well-defined formal language for calculating a function. Starting from an initial state and initial input, the instructions describe a computation that, when executed, proceeds through a finite number of well-defined successive states, eventually producing output and terminating at the ending state. Let's see the example of an algorithm. In this example, we will find the sum of two numbers. Step 1. Start. Step 2. Accept first number from the user. Step 3. Accept second number from the user. Step 4. Add these two numbers. And in the step 5, we will display the results. And step 6. Stop the algorithm. In the next example, we will take three numbers from the users and find the sum of these three numbers. Step 1. Start. Step 2. Accept three numbers from the users. Step 3. Add these three numbers and store the results in one variable. Step 4. Display the results, and in the step 5, stop the algorithm. In the next example, we will find the greatest number. Step 1. Start the algorithm. In the step 2, read three numbers A, B and C, or we can take values from the user and store them in the variable A, B and C. In this step 3, we will compare two variables A and B. Such, for example, if A is greater than B, then we will go to the step 6. If this condition is false, we will go to the step 4. In the step 4, we will check that if B is greater than C, then print B and go to the step 8. If this condition is also false, we will go to the step 5. Print C is the greatest and go to the step 8. In the step 6, we will check if A is greater than C, then print A is the greatest and go to the step 8. In this step 7, we will print the C is the greatest, and in the step 8, we will end the algorithm.